Hello students, today I am here to teach you chapter 25 in your textbook that's called Algebraic Inequalities. Before we start algebraic inequalities, we'll see what are inequalities. Now let's take a number line. When you take number line, we know we put 0 in the middle and to the right side we put positive numbers. So I can write 1, 2, 3 like that, and then we can use an arrow towards this side. What about the negative numbers? So left to 0 we put negative numbers. And then we can put an arrow representing that this is continuing. So when you take the number line and consider two numbers, I want to take 2 and 1. So when you take 2 and 1, which number is greater? So we know that 2 is greater than 1. So how can we write down this one using a mathematical symbol? We know 2 is greater than 1. So we use this symbol. So it looks like a crocodile mouth. So when you take crocodile mouth like this, we can say open side of the mouth is normally greater than the other side. So if the crocodile mouth is this way, so we'll say this is the crocodile mouth. So which side is bigger? Open side of the mouth. So this side is bigger than this side. So we can use this symbol to represent inequality. So here 2 greater than 1. So here I can write 2 is greater than 1. If I want to write other way around, I can start from right hand side. 1 is less than 2. I can write that also. 1 is less than 2. So now we'll take another two numbers. So I want to check 3 and minus 2. How can I write? So 3 and minus 2. Which one is bigger? We know when you take any number on the number line, a number to the right side is always greater than the left hand side number. So which one is to the right? 3 is right to the minus 2. So here this number is greater. So where we put this one? So the open side of the mouth towards 3, because 3 is greater. So we can say 3 is greater than minus 2. If you are starting from the other side, how will you write? We can say minus 2 is less than 3. Now we'll take algebraic inequalities. So what are algebraic inequalities? When we have letters with this symbol, we say algebraic inequalities. Let's take this one. So what it says? So if you start from left hand side, the letter X, what is this symbol? It's greater than. So greater than 2. So how can I write this? X is greater than 2. Can we write 2 is less than X? Normally in algebraic inequalities, we don't write other way around. Always we start with the letter. So X is greater than 2. What about this one? There's an extra line here compared to this one. So that means here this line represent including that value as well. So here how can I write this? crocodile mouth towards 3. That means that number is greater and the other side is less. So I can write x is less than or equal to 3 because there's an extra line. Now we'll take this one. How can I write? So starting with the letter, I can write x is, this side is less than, what about this one? I'll change this slightly. I'll write other way around and see. How can I write this one? I can write, starting with letter, x is, this side is the open side of the mouth. That means this is bigger. X is greater than or equal. Why or equal here? Because there's an extra line. To 7. So you need to remember in inequalities, what are the symbols we can use? We can use 4 symbols, either this one, this side with a line, and this one with a line. So what are these? This means greater than. This one, less than. What is this one? Less than or equal. What about this one? Greater than or equal. So remember those symbols in inequalities. Now we'll take this one. A letter. Any letter you can write here. Instead of x, you can write y. So how can we read this? So starting with the letter, we can write y is, this side is bigger because the crocodile mouth opens to that side. So y is greater than -4. How can I write this one? Try now. Starting with the letter, y is less than or equal to -3. Now here, what's the difference between this one and this one? So the letter, unknown letter onto the right. So we need to start from there. So when we read from that side, this side, the crocodile mouth opens. So we can write y is greater than or equal because there's an extra line to 9. What about this one? There's another unknown letter m. We can write starting from that side, m is less than because the crocodile mouth opens to 7. M is less than or equal to 7. So we'll now see this one. Now slightly different to the previous one. There are 2 numbers and the unknown letter in the middle. How can we say this? Now here, if you close one side, what can you see? X is less than 3. When you close the other side, what can you see? X is greater than -4. So we try to combine these two and figure out what are the numbers satisfied for this inequality. So we can say, if you close this side, we can say x is less than 3. If you close this side, we can say x is greater than minus 4. Now, without writing these two, I can write x is in between minus 4 and 3. So, here instead of these two, I can write x is in between minus 4 and 3. Now, what about this one? Two inequalities. So, this means x is greater than 5. This means x is less than minus 2. So, we'll try to draw these on a number line. Now, we'll take this one. So, if you want to represent this on a number line, okay, we need to mark the number. So, here minus 4 is there. No? So, we can start. We need 0 as well because in between 0 satisfies. So, we'll start from 0 and I'll put 1, 2, 3, 4 like just few numbers. What about other side? I can put minus 1, minus 2, minus 3, minus 4 and another one more, minus 5. Now, we'll try to mark this on a number line. So, here we know first thing x is less than 3. So, here first we can mark number 3. Here when we are marking numbers, if this number is not included, we use open circle. So, here we can put an open circle on number 3. And then this is x is less than. Which side is less? Always on a number line, left hand side is less than the other side. When you take other way around, always right side is greater than to the left side. So, here x is less than 3 means this side. So, this way. What about the other one? X is greater than minus 4. So, we mark minus 4. Here also minus 4 is not included. So, we use an open circle like this. X is greater. Which side is greater? We know that right side is greater. So, here we can mark this way. So, we know the value of x is in between these two. We can continue this line and say x is in between minus 4 and 3. So, this is how we can represent on a number line. Now, we'll take this one. So, first I'll write down what is this? X is greater than 5. What about this one? X is less than minus 2. Now, we'll try to draw the number line. Draw the line and then mark 0 in the middle. Towards right side, we have 5 now, so I have to write 1, 2, 3, 4, 5. I'll put extra number here, 6. What about this side? We have minus 2. So, that means we'll write minus 1, minus 2, minus 3. So, the first thing, mark those numbers. 5 is there. There's no line there. That means 5 is not included. So, we take 5 and then draw an open circle. What about this one? This is also not included. So, we take minus 2 and draw an open circle. So, here we'll mark separately. X is greater than 5. So, which side is greater? Always right hand side. So, here we can mark this side is greater than 5. What about this one? X is less than minus 2. So, this is minus 2, less than is always left side. So, we can mark this side. So, if you are giving x greater than 5 or x less than minus 2, this is how we can mark on the number line. Now, we'll take another one. So in this example it says x is greater than or equal to -2. Write down integral values that x can take. So we'll try with the number line first. So here write down integral values. I'll take the number line and -2 is there. I can start with 0 and mark negative numbers to the left, positive numbers to the right. And then can you see a line there? So that means it's included. -2 is included. So what we do? We can draw a solid circle, not an open circle. So here we color it. Draw a circle and we color inside. So we call it solid circle. So here you can mark -2 there. Greater than -2. Which side is greater? Right hand side. So here we can mark right hand side. But they are asking what are the integral values. So that means the whole numbers that satisfy this inequality. So what are the numbers satisfy this inequality? We see -2 also included. So starting with -2, we can write -2. Okay, then what's the other number? Integral values, that means integers. So we can say -1, 0, 1, 2, but we can't write all because this goes to infinity. So I can write 3 dots representing that it's continuing. So what are the integral values here? I can write -2, -1, 0, 1, 2 and 3 dots. Then here it says represent these values on the number line. Here only these values means we can't draw the line there. So here if you are drawing only the integral values, I can write down. So first draw the number line. So 2 -2 is there. So we can draw a solid circle there. -1, 0, 1, 2, 3 like that. We can mark those points. So that's how we can represent integral values. Now we'll take this one, x is less than 2. So here also they want the integral values satisfying this inequality. So here first we'll draw the number line and see. So when you take the number line, start with 0, positive numbers towards right side, negative numbers towards left side. Here 2 is there but it's not included. So we need to draw an open circle. So here I'll draw an open circle. 2 is not included. So x is less than. So where's less than means? Left side. So we draw this line. Now if you want only the integral values, how can I draw? On a number line, I can draw it again. And see what are the whole numbers satisfied for this inequality. We can't write 2. 2 is not included. So this side, what are the integers? I can see 1 is there. I can write 1, 0, -1, -2, and then I can put 3 dots. So these are the integral values that satisfy for this inequality x less than 2. Now we'll take another example. It says x is in between -2 and 5, and also there's an extra line. Write down the positive integral values that x can take. So without considering positive values, we'll see what are the numbers satisfy for this inequality. So here, if you take the number line, I'll first take the number line. Here 5 and -2 there, so I can start from 0 and mark 1, 2, 3, 4, 5 there, an extra number as well, and starting from this side -1, -2, -3. Now we can mark the numbers. Here we can see equal sign. So equal sign means included. So we can draw five with a solid circle. What about -2? -2 is also included. So we can draw with a solid circle. So here when you close this side, this means x is less than or equal to 5. That means this side. What about this one? X is greater than -2. Greater means right side. So towards this side. So when you connect these two, we can see that these are the numbers satisfied for this inequality. So what are the numbers? When you want to write down the integral values, we can write -2, -1, 0, 1, 2, 3, 4, 5. But they are asking only positive integrals. What are positive numbers? We can write only 1, 2, 3, 4, 5. So here if I write the set of numbers, I can write 1, 2, 3, 4, 5. If I want to represent only the positive numbers, I have to erase this one and write down. I'll erase the whole thing and write down one. So I can put a solid circle because 1 is included. 2, 3, 4, 5. So that's how we can represent the positive integral values on a number line. Now we'll take another example. X is greater than 2. Write down set of real numbers. So what are real numbers? So when you take the number line, any number on the number line are real numbers. It can be whole numbers, negative whole numbers, decimals, fractions, square root values, any number. So any number in between 1 and 2, 1.12, 1.1, 2.5, or any fraction, half, 1/3, or we did in second chapter, square roots, square root of 2, 1.4 something. So all these numbers in between -infinity. So we call this side is -infinity and this side +infinity. So any number in between the negative and the positive infinity values, we call those are real numbers. So if you take this inequality, what are the real numbers? So first we will mark this one 2. 2 should be an open circle because 2 is not included. And this is x greater than 2. So which side is greater? We can write all these numbers to the right side. So this side. So here, if you want to draw this on a number line, we can draw a full line like this. So it can be 2.2, 2.3, any value, but 2 is not included. Now we'll take this one. Draw a number line to represent this. What is this? So we have to start with the letter. Start with letter X. X is less than 3. So if you want to draw a number line, we can mark 0 in the middle and then write positive numbers to the right and negative numbers to the left. And then you can mark 3. How can we mark 3? This is not included, that means open circle. So I can mark with open circle and then less than side. Less than side is towards left side. So I can draw the line to this side. So here any real value less than 3, but 3 is not included. So we'll take another example. X is greater than or equal to minus 2. How can we draw it on a number line? So we'll draw the line and mark the numbers now. And then what's the first thing we can do? We can mark the number. 2 minus 2 is included. So we can draw a solid circle, color the circle. And then greater. Greater means towards right side. So we can draw this line towards this side. So you can draw an arrow like this. What about the other one? Here, when you have two numbers like this, we can say in between. So here, if you take the number line, you can close one side and see x is less than 2. And this side x is greater than minus 3. So here we can mark the numbers like this. And then not included. These values are not included. So we need to draw open circles. And here x is less means this side towards left side. So this way, if you close this side, x is greater than minus 3 towards this side. So here we can see that any number in between these two satisfy for this inequality in between minus 3 and 2. Now we'll take another example. So first one, it says less than or equal to minus 2, and this one x greater than 2. So how can we represent this on a number line? So we can mark numbers like this first. And then, is it an open circle or a solid one? Minus 2 should be a solid circle because minus 2 is included. What about 2? 2 is not included. So we need to draw an open circle like this. So here, when you read the left hand side inequality, x is less than. Less than means left side. The other one, x greater than 2 means to the right side. So this is how we can represent x less than or equal to minus 2 or x greater than 2. Now we'll take this one, x greater than 0. If you take the number line, I'll take this one also, x less than 0. 1, 2. First draw the number line and try to find out the appropriate side. X greater, greater means to the right, so to this side. But 0 is included or not? Not included, so we use an open circle. What about this one? 0 is with open circle, and here less than sign. Less than sign is this one. Now look carefully and see what are the numbers satisfy for this inequality. 1, 2, 3 and 1.1, 2.2, any number above 0. What do you call those? We can say positive numbers. Without writing x greater than 0, we can say these are positive numbers. What about this one? X less than 0. Without mentioning x less than 0, we can say negative numbers. So here we can say negative numbers. So remember this, when you get x greater than 0, that means you get positive numbers. If it's less than 0, you get negative numbers. Now we'll see what are the rules in inequalities. So here we'll take some examples and try to find out what are the rules. So here we'll take two numbers, 8 and 10. Which side is greater? We know 10 is greater than 8. So we can use this symbol, the open side of the crocodile mouth towards 10. Now we'll try to add a number to both these sides. I want to add 2. What happens? Now see what happens to this one. 8 plus 2, 10. 10 plus 2, 12. Now when you look at these answers, which one is bigger? Which one is greater? I can see 12 is greater. So I can use the same symbol that we used before. Now we'll take another one. We'll take minus 3 and minus 6. Which one is bigger? When you take the number line, minus 3 is to the right compared to minus 6. So we can say minus 3 is greater than minus 6. Now we'll add number 2 to both sides. What happens? Minus 3 plus 2 is minus 1. Minus 6 plus 2, minus 4. Now tell me what is bigger. Is it minus 1 or minus 4? We know that minus 1 is bigger. So we can use this symbol. So here we get the same symbol. And I want to do another example. We'll take same example, or we'll take 9 and 12. Which one is bigger? 12 is bigger. So we can use this symbol. Now what I want to do, to subtract a number from both sides. So I want to subtract 2 from both sides. What happens? 9 minus 2, 7. 12 minus 2 is 10. Now, which one is greater? 10 is greater. So I am using the same symbol. I'll take another one. 5 and minus 1. Which one is bigger? 5 is bigger, greater than minus 1. So here I want to subtract. I'll do the same thing. Subtract minus 2 from both the sides. 5 minus 2, you get 3. Minus 1 minus 2, you get minus 3. So which one is bigger? So 3 is to the right side on the number line compared to minus 3. So here we can say 3 is bigger than minus 3. So when you look at all these, what can we say? When we are adding a number to any inequality, or when we are subtracting any number to an inequality, the sign doesn't change. So what we can see, when you are adding or subtracting a number to any inequality, the sign is not changing. So here, that's the first rule you need to learn. I can write here, when you add or subtract a number to any inequality, the sign does not change. That's the first rule you need to learn. Now we'll take the second rule. We'll take again some more examples now. We did addition and subtraction. What are the other operations that we need to do? We need to do multiplication and division. So here we'll take another example, 8 and 10. Which one is bigger? We know 10 is bigger, so we can use this symbol. Now I'm trying to multiply by a number. So I'm multiplying both sides by 2. 2 times 8, 16. 2 times 10, 20. Now see which side is bigger. 20 is greater than 16. So I can use this symbol. So here, same symbol. Now we'll take another one. I'll take minus 1 is greater than minus 5. Because minus 1 is towards the right side on the number line. So here, multiply by 2 both sides. Minus 1 multiplied by 2, you get minus 2. Minus 5 multiplied by 2, you get minus 10. Now which one is bigger? We know that minus 2 is greater than minus 10. So we can use this symbol. Now we'll take division. So we'll take another number. We'll take 9 and 12. Which one is greater? 12 is greater. I can use this symbol. Now I want to divide both numbers by 3. 9 divided by 3 and 12 divided by 3. What's the number? 9 divided by 3 is 3. 12 divided by 3 is 4. Now which number is greater? Compared to 3 and 4, I can see 3 is greater. You get the same symbol. I'll take another one. I'll take minus 2 and minus 4. Which one is bigger? We know that minus 2 is bigger or greater than minus 4. I want to divide both sides by 2. Minus 2 divided by 2 and minus 4 divided by 2. So what you get? Minus 2 divided by 2 is minus 1. Minus 4 divided by 2 is minus 2. Which one is greater? When you take the number line, minus 1 is towards the right side than minus 2. So I can say minus 1 is greater than minus 2. So what can we say about this one? When you are multiplying or divide any inequality, what happens? The sign does not change. And also you need to remember, you divided by positive numbers as well as you multiplied by positive numbers. So we can write the second rule. When you multiply or divide by positive numbers, of an inequality, the sign what happens? The sign does not change. You get the same sign. The sign does not change. So we did two rules now. When you add or subtract a number, the sign of the inequality does not change. When you multiply or divide by a positive number, the sign does not change. Now we'll see what happens when you multiply or divide by a negative number. We'll take again another example. 8 and 10. We'll take the same thing. 8 and 10. Which one is greater? We know that 10 is greater than 8. Now I want to multiply this by minus 2. 8 times minus 2, you get minus 16. 10 times minus 2, you get minus 20. When you look at the number line, which one is to the right side? Compared to minus 20, we see minus 60 is onto the right. So minus 16 is greater than minus 20. Now what happens to the sign? The sign changes. Earlier it was less than, now it is greater. We'll take another one. We'll take 2 is greater than minus 1. I want to multiply this by minus 2. 2 times minus 2, minus 4. 2 times minus 1 times minus 2, you get plus 2. Now which one is bigger? We see 2 is greater. So we have to use this symbol for this when you compare these two numbers, minus 4 and 2. So what happens again? The sign changes. Now we'll try with dividing by a negative number. I'll take the same inequality, 8 and 10. I'm now dividing this by minus 2. So 8 divided by minus 2. 10 divided by minus 2. What happens? 8 divided by minus 2 becomes minus 4. 10 divided by minus 2, you get minus 5. Which one is bigger? We see minus 4 is bigger than minus 5. So you have to use this symbol. minus 4 is greater than minus 5. So what happens now? The sign changes. We'll take another one. We'll take 3 and 9. Which one is bigger? I can see this one is bigger. 9 is bigger than 3. I want to divide this by minus 3. So 3 divided by minus 3 and 9 divided by minus 3. So what happens? 3 divided by minus 3 becomes minus 1. 9 divided by minus 3 is minus 3. Now which one is bigger? Minus 1 is greater than minus 3. So what happens here? Here also the sign changes. So what can we say now? When you are multiplying or divide by any negative number, the sign of the inequality changes. So here I'll write here, this is the other important rule in inequalities. When you multiply or divide an inequality, by a negative number, the sign does change. So this is important. So remember that we did several rules. When you are adding or subtracting numbers, nothing will happen to the sign. When you multiply, divide by a positive number, nothing will happen to the sign. Only when you are multiplying or divide by a negative number, the sign is changing. So remember that when you are dealing with questions related to inequalities. Now we'll take an algebraic expression like this, and they are asking to show results on a number line. So what can we do? Now we learned rules, several rules, so we have to apply those in these algebraic inequalities. So we'll take the first one, 2x plus 3 less than or equal to 7. So this is like normal algebraic expression. So if you are considering this one as equal sign, this is simple algebraic expression, and you need to, if you want to solve, what we do? We take letters to one side and numbers to the other side. So what can we do here? We need to take x terms to one side and get rid of all the numbers to the other side. So here 3 is extra. So I can get rid of 3 first. So what I can do? I can subtract 3 from both these sides. So we know according to the rule, nothing happens to the sign. So I can use the same sign. So 2x plus 3 and minus 3 get cancelled out. You get 2x here. 7 minus 3, you get 4. Sign is not changing. Now we need to find x. So there's extra 2. What we do to get rid of this 2? I can divide both the sides by positive 2. So when I divide this by 2, what happens? 2 get cancelled out and you get x here. 4 divided by 2 is 2. So the sign is not changing because we divide by a positive number. So here what can we say? You get x less than or equal to 2. If you want to show this on a number line, draw the line and mark 0, 1, 2, 3, several numbers close to this one and minus values as well. This is equal to 2 as well. So what we do? we draw a solid circle here, and then how we read? Starting from the letter, x is less than or equal to 2. So we can mark towards left side. So we can say always left hand side is less than the right hand side. So here this is the number line for this inequality. Now we'll take this one, the next one. 7x minus 3 greater than 4. We need to first get rid of this minus 3. How can we get rid of this? So I can add 3 to both sides. So when I'm adding this one, minus 3 and plus 3 get cancelled out, and then you get 7x. 4 plus 3 becomes 7, but the sign is not changing. Then what can I do? I can divide this by 7, positive 7. When I'm dividing by positive 7, again sign is not changing. I can write x, 7 divided by 7 is 1. X greater than 1. How can I show this on a number line? I can mark the numbers like this. 1 is not included, so I can draw an open circle like this, and greater means right hand side, so I can mark that side. Now we'll take another expression like this. So here what's the difference compared to the previous one? Previous one only we got x term on one side. Now in this inequality you have x's in both sides. So you have to take all x terms to one side and the numbers to the other side. So we'll start with this one. So I want to take x terms to left side and numbers to the right hand side. So I can get rid of this minus 1 first. So I can add 1. Then what happens to the inequality? Minus 1 and 1 get cancelled out and I get 5x. And you get the same symbol. 3x is there. 5 plus 1 becomes 6. Now I need to get rid of this 3x there. So I can subtract 3x from both sides. So what we get? 5x minus 3x becomes 2x. 3x get cancelled out and I get 6 here. So we get the same symbol. Now I want to get rid of this 2. I am dividing both sides by 2. What you get? 2 get cancelled out. I am getting x greater than or equal to 6 divided by 2 is 3. If you want to show this on a number line, what you do? Draw the line, mark several numbers close to this one, 3. I can draw minus numbers as well. Here 3 is included. So here I can draw a solid circle and x greater than. Which side is greater? Greater means towards right hand side. So I can use an arrow to represent it goes towards right hand side. Now we'll take another one. 7 minus 3x is less than 1. So I can keep x's in this side and take numbers to the other side. So I want to get rid of this 7. I can subtract 7 from both sides. So what happens when you subtract? You get minus 3x. 1 minus 7, you get minus 6. Nothing will happen because we just subtract a number. So what happens here? When you subtract minus 7, you get minus 3x. 1 minus 7 is minus 6. Now, I want to get rid of this minus 3. So what I can do, I can take the inequality and divide this by minus 3. So what's the rule? When you are dividing by a negative, the sign changes. So now you can't use this symbol. So you have to change it to the other side. So I can write this way now. So here when you divide minus 3 get cancelled out. I get x is greater than minus 6 divided by minus 3. You get 2. So here what's the answer? X is greater than 2. If you want to draw the number line, just mark several numbers close to that one. And then here 2 is not included. That means you have to draw an open circle. So here 2, an open circle. This is greater. Greater means right hand side. So I can draw towards this side and use the arrow to represent this inequality. Now we'll look at the example 1 in your textbook. So it says solve the inequality x plus 20 greater than 50 and write down the set of integral values that x can take, and also represent these integral values on a number line. So first we'll take the inequality x plus 20 greater than 50. How can I solve this? I need to get rid of this number 20. So I can subtract 20 from both sides. Then what happens? 20 get cancelled out. I get x here. 50 minus 20, I get 30. So here greater than also not changing because we just subtracted 20 from both sides. So here x greater than 30. They are asking integral values that x can take. If you take the number line, now here you don't need to start from 0 because here the number is 30. So otherwise what happens? You have to write 0, 1, 2 up to 30. No need. So you can start with any number close to 30. So I can write 30, 31, 32, 33 like that, and then numbers less than this, 29, 28, something like this. And then 30 is the number, so you can draw an open circle because 30 is not included, and x is greater. Which side is greater? Greater side is towards right side. So I can draw a line towards this side. Now what are the integral values that satisfy this? So greater means here 30 is not included. So I can write down 31, 32, 33, and I can put 3 dots representing that it's continuing. And if I want to represent this one on a number line, so these are the integral values, and I'm trying to show that on a number line like this. You can't draw a line here. Why? Line represent real numbers, all numbers in between 30 onwards. So here integral means only whole numbers. So here 33, I can write down. 31 is there, so I can draw a solid circle. 32, 33, like that. So here these are the positive, not positive, integral values x can take on a number line. Second example, it says solve the inequality minus 3x greater than or equal to 12 and represent all the values that x can take on a number line. Here, what's the difference between the previous example and this one? It says all the values. So that means real numbers. So first we'll try to solve this. The inequality is minus 3x greater than or equal to 12. Now we need to get rid of this minus 3. So what you do? Take the inequality, divide by minus 3. What happens? When you divide by negative number, the sign changes. So here you can't write this one. We have to write down the opposite sign. Less than or equal to this number. So here 3 get cancelled out and you get x is less than or equal to 12 divided by minus 3 becomes minus 4. So what are the numbers now? If you want to draw on a number line, what can we do? First, you can start here with 0, put the negative numbers and several positive numbers. Minus 4 is included, so make sure that you draw a solid circle. And then you can draw the line towards which side? X is less than or equal. That means towards left side. So here not only integral values, here all values that x can take using the line. Now we'll take the review exercise in your textbook and try to answer these questions. So the first question, solve each of the following inequalities. So the first one, what can we do? We have to get rid of this 4. Subtract 4 from both sides. Minus 4 and 4 get cancelled out. X is greater than 11 minus 4 is 7. So they are asking just to solve. So you don't need to draw the number line. So this answer is x greater than 7. What about this one? Take the inequality. Here 3 is there, so we need to get rid of this 3. Subtract 3. So what happens? 3 get cancelled out. Y is less than or equal to 0 minus 3 becomes minus 3. So here what's the answer? Y is less than or equal to minus 3. Now take this inequality. P minus 5 less than 2. So there's an extra minus 5. How can I get rid of that? I can add 5 to both sides. Then minus 5 plus 5 get cancelled out and I get P here less than 2 plus 5 is 7. What's the other one? We'll take the next one. P minus 3 is greater than minus 1. Minus 3 is extra, so I need to get rid of that by adding 3. So what happens? Minus 3 get cancelled out and I get P is greater than minus 1 plus 3, you get 2. So P is greater than 2. Now we'll look at the other parts. So in this one, what happens? A plus 5 is less than or equal to 1. 5 is extra. I need to get rid of that by subtracting 5 from both sides. 5 get cancelled out and remaining A. 1 minus 5, I get minus 4. So you get the same symbol. So A is less than or equal to minus 4. What happens here? 5y less than 12. You need to divide this by positive 5. So I can divide both sides by 5. 5 get cancelled out. You get y is less than 12 divided by 5. What's 12 divided by 5? So you can just divide and see. 5 times 2, 20, and I can write, if I want a decimal value, 20, so you get 2.4. So I can write y is less than 2.4. What about this one? Take the inequality. There's a minus sign in front. So you need to divide by minus value. So can we straight away divide? No, we have to change the sign when you are dividing by a negative value. So here now you get this symbol, not the previous one. So minus 2 get cancelled out. You get x is less than or equal to 10 divided by minus 2 becomes minus 5. What's the other one? Minus 3y is less than minus 9. Here also you need to divide by minus 3. So what happens when you are dividing by a negative? The sign changes. So minus 3 get cancelled out. Y is greater than minus 9 divided by minus 3. You get positive 3. So the answer is y greater than 3. Now we'll look at the last part of question number 1. Minus 2x over 3 greater than 6. We'll take that question. What can we do? We have to get rid of this 3. So to get rid of this, you have to do the opposite one. So this is dividing by 3. So you multiply both sides by positive 3. So what happens? 3 get cancelled out. You get negative 2x is greater than 6 times 3, 80. Now to get rid of this minus 2, I need to divide this by minus 2. When you are dividing by a negative, what happens? Can you remember? The sign changes. So here greater than side becomes less than side. So minus 2 get cancelled out. You get x. So 18 divided by minus 2 is minus 9. So this is the answer for part 9. Now we'll look at question number 2. Solve each of the following inequalities and represent the solutions on a number line. So here you have to draw a number line for second question. Now we'll start from the first one part. X plus 3 greater than or equal to 1. So what's the first thing? Get rid of this 3. I can subtract 3 from both sides. And then 3 get cancelled out. I get x here. Greater than or equal to 1 minus 3 becomes minus 2. So how can I represent on a number line? Mark numbers close to this one first. I can mark several numbers. Here minus 2 is included, so I can draw a solid circle. Then which side I should mark? X is greater than minus 2. Greater means to the right. So I can draw towards this side. And we'll take the next one. Y minus 4 less than minus 1. I need to get rid of minus 4. Add 4 to both sides. What happens? Minus 4 and plus 4 get cancelled out. You get y minus 1 plus 4. You get 3. So y is less than 3. So how can I draw this one? So I can mark 0, 1, 2, 3, 4 like that. And then minus 1, minus 2, 3 with an open circle. And then less than 3. So less than 3 means towards left side. We'll take the third example. 3x is greater than minus 3. So here we need to get rid of this 3. So I can divide both sides by 3. So 3 get cancelled out. I get x greater than minus 3 divided by 3. You get minus 1. Now how can I draw the number line? I can mark several numbers close to minus 1 and then mark minus 1 with an open circle. And then which side satisfies this inequality? X is greater. Greater means towards right hand side. And we'll take this part. X divided by 2 is less than or equal to 0. This is divide by 2. So we need to do the opposite operation, multiply by 2. So here I can multiply both sides by 2. So nothing will happen to the sign because we are multiplying by a positive number. So here 2 get cancelled out, you get x less than or equal to 0 multiplied by any number, you get 0. So here how can I show this on a number line? I can mark 0, 1, 2, minus 1, minus 2. 0 is included. I can draw a solid circle and x less than or equal. Which side? Which side you need to mark? Left hand side, because this is less than side. So here we can mark like this. What about the other one? Minus 5y is greater than 10. Here you need to divide by minus 5. So what I can do, I can divide both sides by minus 5. But the sign changes. So greater becomes less than. So here 5 minus 5 get cancelled out. You get y. 10 divided by minus 5, you get minus 2. You get y is less than minus 2. How can I mark this on a number line? I can first write down several numbers close to minus 2 and then minus 2 with an open circle and consider less than side. So how can I mark it? Towards left hand side. Now we'll take the next one. Minus 4x and 12. I need to get rid of this minus 4. So what I can do, I can divide both sides by minus 4. But I need to change the sign because I divided this by minus 4. So here earlier greater than or equal to, now it should be less than or equal. So minus 4 get cancelled out. You get x less than or equal to 12 divided by minus 4. You get minus 3. So how can I draw on a number line? I can mark several numbers close to minus 3 and then mark minus 3 with a solid circle and then consider less than side. Less than side means towards left side. So here this is how I can mark x less than or equal to minus 3. Question number 3. For each of the following inequalities, one of the values of x which satisfy the inequality is given within the bracket. Select that value and underline it. So we need to check which one is suitable for this inequality. So we'll first solve this and see what's the solution. So this is the inequality given. So we need to subtract 3 from both sides to get rid of this 3. 3 and minus 3 get cancelled out, you get x. 7 minus 3, you get 4. Here nothing will happen to the sign. So x greater than 4. So any number greater than 4 satisfies this inequality. Now look at this one. First x value is given is 4. But here 4 is not included. So we can't take 4. What about 7? Yes, 7 is greater than 4. So what's the solution there? 7 is the appropriate value, satisfies this inequality. Now we'll take the next one. The inequality given x minus 3 is less than 2. I need to add 3 to both sides. So what happens? Minus 3 plus 3 get cancelled out. I get x. 2 plus 3 becomes 5. So here x less than 5. So any value less than 5 satisfies this inequality. Now look at 1. 1 is less than 5, but 6 is greater than 5. So what's the suitable x value for this inequality? We can say 1 is a suitable value. Now we'll take the next one. 3x is greater than 7. So you need to divide this by 3. Nothing will happen to the inequality sign. When you divide by 3, you get x here. 7 divided by 3. Roughly how much? 3 times 2, 6. For 10, like 3. 3 times 3, 9. Again 3, 3 like. So 2.3. So I can write 2.33. Correct to 2 decimal places. So any value greater than 2.33. So here this value 2.3 is less than 2.33. What about 8 divided by 3? What's the value 8 divided by 3? 3 times 2, 6. 2 remaining. 3 times 6 is 18. 2.6. So is 2.6 is greater than 2.33? Yes. So here the suitable value for this one is 8/3. Let's take the next one. Minus 2x less than 8. So we can divide this by minus 2. When you divide this by minus 2, what happens? X, I'll write it down, minus 2x, 8, divide by minus 2. Here, remember to change the sign because you are dividing by a negative number. So, x becomes greater than 8 divided by minus 2, you get minus 4. So, x greater than minus 4. So, when you take the number line, if it's minus 4, greater than means this side. Minus 3, minus 2, this way. So, which number satisfies the inequality? 3, because minus 5 is on the other side. So, 3 is the correct number. Next one. 5 minus x is greater than 6. So, minus x is greater than, take 5 to the other side. 6 minus 5, you get 1. Now, divide both sides by minus 1. What happens here? Change the sign of the inequality. 1 divided by minus 1 is minus 1. X less than minus 1. When you take the number line, if it's 0, minus 1, minus 2 like that, x less than minus 1 means this way. So, which number satisfies that inequality? Minus 2. Take the fourth question. It says, solve the inequality x plus 1 greater than minus 2 and write down the smallest integral value that x can take. Okay, we'll try the first part. First, take the inequality and try to solve. So, here you have to get rid of this 1, subtract 1. So what happens? 1 get cancelled out, you get x greater than minus 2 minus 1 becomes minus 3. So x greater than minus 3. So here write down the smallest integral value. Now if you take the number line, here you can write down what are the integral values satisfy this one. Minus 3 is not included, so you don't take that. But you can take minus 2, minus 1, any value towards the right hand side. So here what's the smallest integral value? So the smallest integral value is minus 2. So you can write minus 2 is the smallest integral value. What about the second part? It says minus 3y greater than 15. Okay, so here you have to divide by minus 3. So I'll divide both sides by minus 3. So 15 divided by minus 3 is minus 5. Minus 3 get cancelled out. This is y. So we know that when you divide by a negative number, the sign is changing. So you have to use the other way around. So y is less than minus 5. So if you are drawing the number line, so I can mark several numbers close to minus 5. And then y is less than minus 1. So which side is less than side? So less than side means towards left side, and minus 5 is not included. So what's the largest integral value? Now when you get to the left hand side, the value becomes smaller and smaller. So what's the largest value for this one? We can say the largest value is minus 6. Now we'll take fifth question. It says solve the inequalities x plus 3 greater than 1 and 2x less than or equal to 12 and represent all the solutions on a number line. So we have to take both inequalities and solve separately and draw one number line. So how will you solve? Subtract 3 from both sides. 3 get cancelled out, you get x here, 1 minus 3 is minus 2 and you get the same symbol. What about this one? You divide the both sides by 2, you get x less than or equal to 12 divided by 2 is 6. So you get x less than or equal to 6. Now we'll try to draw the number line. So here you can mark the negative numbers and I need up to 6 now. So here first we'll do x greater than minus 2. So here minus 2 is not included. So we draw an open circle. X less than or equal to 6 means x is included. You draw a solid circle. Now try to draw the appropriate sides. X greater. Greater means towards right side. So this way. X less than or equal to plus 6 towards left hand side. So that means any value in between these two satisfy these two inequalities. So what are the values? So either minus 1, 0, 1, 2, 3, 4, 5, 6 if they ask the integral values, but here they are just asked draw these two inequalities on a number line. So here is a solution. Now we'll take example 1 in your textbook. So look at the question. It says, Nimal, who constructed a rectangular structure of breadth 5, it's given there and shown in the figure, using 30 centimeter long piece of wire, saved a small piece of the wire. If the length of the rectangle is taken as x, here x is given, an inequality in terms of x involving the perimeter of the rectangular structure is given by this. So they have already given the inequality, 2x plus 10 less than 30. On a number line, represent all possible values that x can take if x is greater than 5. So there's another inequality given, x is greater than 5. First, we'll try to solve this inequality. So how can we solve? We can get rid of this 10 from both sides. You get 2x is less than 30 minus 10 is 20. Divide both sides by 2. You get x less than 20 divided by 2 is 10. And also x greater than 5. Now we'll try to draw the number line and see. So here 5 and 10 there. So I can write 5, 6, 7, 8, 9, 10 and several numbers before and after. Both these numbers are not included, so I can mark with open circle 10 and 5. Now we'll try to mark the appropriate side. X is less than 10, that means towards left side. X is greater than 5, that means when you take this number towards right. That means any number in between these two satisfy the length of x. So that means what are the integral values you can take? You can take 6, 7, 8, 9. But they have just asked on a number line, show all possible values. So here it can be a decimal value as well. So that's why we can draw this line. Now we'll take example number 2 in your textbook. It says solve the inequality 3 minus 2x and on a number line represent all possible values that x can take. So first thing we have to solve. So you can get rid of this 3 by subtracting 3 from both sides. Then you get minus 2x. 9 minus 3 becomes 6. Nothing will happen to the sign because we just subtracted a value. Now what happens? Now there's minus sign. We need to divide by minus 2. When you are dividing by a negative, the sign changes and you can write 6 divided by minus 2 is minus 3. This is greater than or equal. So how can we represent this on a number line? So we can mark several numbers close to minus 3. And then this is equal as well. So solid circle on top of minus 3. And then look at the side, greater. X is greater than or equal to minus 3. That means towards right hand side. So that's what it asks here. Represent all possible values that x can take. Now we'll look at the exercise 25.1 in your textbook. So in the first question it says solve each of the following inequalities. So you don't need to draw the number line. So we'll try to solve all these inequalities. First take the first one. Try to get rid of this one. That means subtract 1 from both sides. What happens? You get 4x here. 5 minus 1 becomes 4 and the sign is not changing. Here you have to divide by 4. What happens to the inequality? Sign is not changing because you divided by a positive number. 4 divided by 4, you get 1. So here, what's the solution? X is greater than 1. Now try this one. Same as before. Take the inequality. Try to get rid of the number here. So minus 3. I need to add 3. What happens? You get 5x here. 7 plus 3 becomes 10. Nothing will happen to the sign. Divide this by 5. Why? We need to find x. You get x. 10 divided by 5 is 2. So what's the answer? X is less than 2. Now we'll take the third one. So here 3 is extra. Try to get rid of that by subtracting 3 from both sides. You get 2p greater than or equal to 1 minus 3. What is 1 minus 3? Minus 2. Now to get p, you need to divide both sides by 2. You get p is greater than or equal to minus 2 divided by 2. You get minus 1. Now what about fourth part? So we'll write down the fourth part. So the question says 7x plus 9 is less than minus 5. So here you need to subtract 9 from both sides. So 9 get cancelled out. You get 7x here. Minus 5 minus 9 minus 14. Now you have to divide this by 7 both sides. What happens? X is less than. Minus 14 divided by 7 is minus 2. Now we'll look at the next few parts. So in this one also you do the same thing. Try to take numbers to the other side. So what can we do? We can add 5 to both sides. 5 get cancelled out. You get minus 2y is greater than. 1 plus 5 becomes 6. Again, here it's a negative value. When you are dividing by negative 2, the sign is changing. So here, what happens here? You get y is less than. 6 divided by minus 2 is minus 3. Now we'll take this one. 3 minus 4x is greater than 3 or equal to 3. Here 3 is extra. You need to get rid of this 3. When you are subtracting 3, what happens? 3 get cancelled out. You get minus 4x greater than or equal to 3 minus 3 becomes 0. Now what happens? We need to divide this by minus 4. When you are dividing by minus, the sign changes. So you have to change the sign. So what happens here? X less than or equal to 0 divided by any number is 0. So the answer is x less than or equal to 0. Now we'll take the next one. 8 minus 4y is less than 0. Here also we have to get rid of this 8. Subtract 8 from both sides. 8 get cancelled out. You get minus 4y less than minus 8. Now we have to divide this by minus 4. So what happens? Remember, when you divide by minus, the sign changes. So you have to change the sign when you are dividing by a negative number. So minus 4 get cancelled out. Y is greater than minus 8 divided by minus 4. You get plus 2. So the answer is y greater than 2. Now look at the next one. What's the difference there? There's a bracket also. So you need to get rid of the number in front. So what's the first step you can do? First thing you can do, you can get rid of this number 2. So I can divide both sides by 2. When I divide this by 2, this 2 get cancelled out and you are getting 3 minus x greater than 10 divided by 2 is 5. Now you have no brackets. So we can solve it easily. So how can I get rid of this 3? I can subtract 3 from both sides. You get minus x is greater than 5 minus 3 becomes 2. Now how can I get 1x, not minus x? I can divide this by minus 1. So what happens to the sign? The sign changes because I divided by a negative number. So here minus minus get cancelled out and you get x is less than 2 divided by minus 1. You get minus 2. So what's the answer? X less than minus 2. Now we'll see the second question. Solve each of the following inequalities and write down the set of integral solutions of the inequality. That means you don't need to draw the number line, just write down the solutions. So what we can do? First take the inequality, try to solve. Get rid of this 1. That means you have to subtract 1 from both sides. So you get 5x there, minus 4 and minus 1 becomes minus 5. Nothing happens to the sign. Again, to get 1x, we need to divide by 5. So divide by 5, what happens? You get x here, minus 5 divided by 5, you get minus 1. So x greater than minus 1. So they are asking set of integral solutions. So here, what are the solutions satisfy for this inequality? Minus 1 is not included. When you take the number line, what's the next number? 0, 1, 2, 3 like that. So here greater means right hand side. That means what's the integral solutions? You can take 0, 1, 2, 3 and you can put 3 dots to represent this is continuing. And what about the next one? You have 3y minus 1 greater than or equal to 2. Try to get rid of this 1 by adding 1 to both sides and then you get 3y greater than or equal to 2 plus 1 becomes 3. Again, divide by 3 to get y. So here y is greater than or equal to 3 divided by 3 is 1. Now if you take the number line, 1 is there. Greater than or equal to 1. Here 1 is included there. So this side. So what are the set of integral values that satisfy this inequality? You can start with 1, 2, 3, dot, dot, dot. That means this is continuing. What about the third part? Take the inequality and you have to get rid of this minus 4. So we are adding 4 to both sides. So minus 4 plus 4 get cancelled out. You get minus 2p is less than 4. Now there's a minus sign. So you have to divide by minus. So what can we do? We are dividing by minus. The sign is changing. So here make sure that you write the other sign, greater than sign. So minus 2 get cancelled out. P is greater than 4 divided by minus 2. minus 2. So P is greater than minus 2. So when you look at the number line, greater means towards right side, but this is not included. So any value to this side. So what's the set of number? You can start with minus 1, 0, 1, 2, and this is continuing. Now fourth one, it says 7 minus 4p greater than 3. Here we have to get rid of this 7. So what I can do, I can subtract 7 from both sides. I get minus 4p is greater than 3 minus 7. So what is 3 minus 7? Minus 4. Now you get a negative value, so I need to divide this by negative 4. So what happens here? The sign changes. So you get P is less than minus 4 divided by minus 4, that's 1. So P is less than 1. So when you look at the number line, 1 is not included and this is less than. So that means any value towards to left. So what are the set of integral values you can take? You can't write 1. You can write 0, minus 1, minus 2, any number less than side. Now we'll take question number 3. So it says 100 rupees is sufficient to buy 3 mangoes and 2 mandarins. If the price of a mango is 20 and the price of a mandarin is taken to be y rupees, then an inequality this in y can be written. Solve this inequality and find the maximum value that the price of a mandarin can take. So first you need to check whether you are getting this inequality. Now it says it's sufficient to buy 3 mangoes and 2 mandarins. So here they say the mango is 20 and the price of a mandarin is y. So here if you take this question, we'll write down separately. Mango, the price is 20 rupees and mandarin rupees y. But it says 3 mangoes and 2 mandarins. So here what's the price for mangoes? One is 3 rupees, one is 20 rupees and 3 mangoes you are buying. So 20 times 3 is the total amount you have to pay for mangoes. What about mandarin? One mandarin is y rupees, but you are buying 2 mandarins. So here what's the full price? 2 times y, or you can write 2y. So this is the price for mangoes, that's 60 rupees. Price for mandarins, 2y. So what's the total price you need? Total value is 60 plus 2y. Now it says sufficient. What is sufficient means? That's enough. 100 rupees is enough to buy 3 mangoes and 2 mandarins. So here that means the total price should be less than or equal to 100 because it's sufficient. So now we'll check whether we got the same inequality. Yes, we got the same one. Now they are asking to solve this inequality. So we'll take the inequality, try to solve it. 60 is extra, so you subtract 60 from both sides. You get 2y is less than or equal to 100 minus 60 becomes 40. Now you have to divide both sides by 2. You get y is less than or equal to 20. So here we solve the inequality and find the maximum value that the price of a mandarin can take. So here y is the price of the mandarin. It says y should be less than or equal to 20. If you take the number line, what can we say? 20 is included. So you can mark with a solid circle 20, and this one is less than or equal. That means to the left. So what is the maximum value? So this is the maximum value. So 20 rupees is the maximum value for one mandarin. Now we'll take the fourth question. So it says, Nimal, who placed a 1 kilogram standard weight in one pan of a balance scale, placed a 500 gram standard weight and 3 cakes of soap of the same type on the other pan. He observed that the pan with the 1 kilogram standard weight dipped below the other pan. If the mass of a cake of soap is taken as P grams, an inequality this in terms of P can be written. Find the maximum integral value that the mass of the cake of soap can be. So here, what can you say about this? So if the balance is this way, we can see that this side is greater than this weight. So but look at the weights, one is in grams and the other one is in kilograms. So you need to write both in one unit. So it's easy to convert to grams. So how many grams in 1 kilogram? You get 1000. So here we can see this side is 1000 grams. What about this one? In this question it says 3 cakes of soap here. So 1 soap is P grams. So how about 3 cakes of soap? So that's 3P. So that's the weight of soaps. Weight of 3 soaps. That's 3P. Now what's the total weight on this side? On the left right hand side, we get 500 and 3P. This is also in grams. It's given P grams. So here both are in grams. So here this is the total weight on right hand side. What about the left hand side? Left hand side is 1000 grams, but we can see this side is greater. So we can write 1000 grams is greater than 500 plus 3P. Now we'll check whether we got the inequality. Yes, 1000 is greater than 500 plus 3P. Now they are asking to solve this inequality. So we'll try to solve 1000 greater than 500 plus 3P. So here I can write the same thing other way around. Normally we keep the unknown letter onto the left side. So I can write same thing this side. Now this is less than 1000. Now we'll try to solve. I want to get rid of this 500. Subtract 500 and you get 3P is less than 1000 minus 500 is 500. When you divide by 3, what happens? P is less than. Divide by 3. 3 times 1, 3. 2 remaining. 3 times 6, 18. 2 remaining. 3 times 6, 18. 2 remaining. So you get 2/3. So this is the inequality we got. So here it says what's the maximum integral value that the mass of a cake of soap can be. So here this is less than means towards left hand side, and this is not equal to this value. So what's the maximum value we can take? We see that less than this value is 166 grams. So that's the maximum value that can take for P value. Now we'll look at how to represent regions using inequalities. Now so far we just found out how to represent inequalities using number line. Now we'll see, this is a Cartesian plane and you're asked to show with a region. Now we'll take this equation, x equals 2. How can we draw this line, x equals 2 line? Can you remember you did before? Always the x value is 2 and you can take any y value. So what type of line you are getting? So for example, you can take any point when x equals 2, y can be 1. X equals 2, y can be minus 1. When x equals 2, y can be 4. So when you are marking these points, 2 and 1, so this is the point. 2 and minus 1, you are getting here. 2 and 4, here. So if you want to draw this line, so passing through all these points, we can draw this line. That's the x equals 2 line. Now we'll take points to identify the region. I'll take 4, 4. This one. I'll take this one as P. Another point, 7 minus 3. This point. Another one, 5 minus 8. Now these 3 points on the right hand side to this line. Look at carefully the x values. 4, 7, 5. All these values are bigger than 2. So which region is this side? This region is x greater than 2. X greater than 2. But here this is a continuous line, x equals 2. So you can say this is x greater than or equal to 2. So now we'll look at another example with x equals minus 1. Now we know when you get an equation like x equals something, we know it's a vertical line. So here always the x value should be minus 1. So you can take any point, x equals minus 1, minus 1, 1, minus 1, 5, minus 1, 9, minus 1, minus 3, minus 1, minus 7. So what's the equation of x equals minus 1? You can draw this line. So I can draw this line for x equals minus 1. Now, if I want x less than 1, minus 1 to shade, which region I should take? Now we'll take with any point. So I'll take this point, any side, and we can check. What is this point? 3, 5. This is minus 1 line. 3 is bigger than minus 1 or greater than minus 1. But we need x less than minus 1. So that means this point is not satisfying this inequality. If you take any value here, this side, I'll take this point. What are the coordinates? You get minus 4 and minus 6. So minus 6 minus 4. When you look at with the x value minus 1, we know minus 6 is less than minus 1. So that means if you want to shade this region, we can see that this region satisfy the inequality x less than minus 1. But do you think this is correct? Something wrong. What's the mistake? This is not equal to minus 1. So we can't draw a continuous line like this. So what's the line we have to draw? We have to draw a dashed line, not a continuous line. So here, so what we have to draw? We have to draw a dashed line along x equals minus 1, not a continuous line. Why? What's the reason? Because this is not equal to minus 1. So remember, when you want to shade any region, so you have to first see whether the value is included or not. If the value is included, you can draw a continuous line. If the value is not included, you have to draw a dashed line. So we'll take another example, x less than 3. This is also a vertical line. So what's the vertical line? X equals 3. So here that means always the x value is 3 and you can take any y value. But this is not included, so that means you have to draw a dashed line along x equals 3. Then which region satisfy? You can check with a point. I'll take any point here. I'll take this one. What are the coordinates? 6 and 1. When this is x equals 3. When you look at x coordinate, 6 is greater than 3. So that means this side is greater than side. So how can we mark the less than side? So we can mark the less than side as this one. So here this is the shaded region satisfy x less than 3. Now we'll take another example. Now we have y, not x. Earlier x equals something, it's a vertical line. Now what do you think about y equals something? Check that out. So that means you can take any x value. So here, if you want to draw the y equals 2 line, y is always 2. You can take any x value. So I'll take 0, minus 1, 3, any x value. So here 0, 2. So where's 0, 2? Somewhere here. Where's minus 1, 2? Somewhere here. Where's 3, 2? Somewhere here. That means you have to draw a horizontal line. But here, can we draw a continuous line or a dashed line? Which one is suitable? 2 is not included. So 2 is not included means you have to take a dashed line. So here, what can we do? We can draw a line along y equals 2, that is a horizontal line. So we can write this line is y equals 2, and which side greater than 2? We'll take a point. So if you take any point here, what can I say? This is 5 and minus 6. So minus 6 and 5. When you look at y value, 5 is greater than 2. So this side satisfied y greater than 2. So we can shade it if you want y greater than 2. So this is the region. Satisfy y greater than 2. This is y greater than 2. Now we'll take y less than or equal to minus 2. We'll try to sketch this one in the same Cartesian plane. So what's the first step? We need to draw the line y equals minus 2. This is equal as well, so you have to draw a continuous line. So we'll first draw the continuous line. Y equals minus 2 is a horizontal line. We'll take this line, y equals minus 2 line. So this is y equals minus 2. We'll take several points and identify the region. You get two regions, down and up. We'll take one point, this one. What's the point? Minus 7, minus 6. You have to now compare the y values. This is minus 2. This point is minus 6. Which one is smaller? Minus 6 is smaller than minus 2. So, what is this region then? This region is y less than or equal to minus 2. So, we can mark it, this one, as y less than or equal to minus 2. Now we'll look at the exercise 25.2 in your textbook. So it says in the first question, write down the coordinates of 3 points belonging to the region x less than minus 2. So here less than means the x value should be less than that. So what are the values less than minus 2? You can take minus 3, minus 6, minus 9, and you can write any 3 coordinates. So what I can do, I know the x value should be less than minus 2, so I can write minus 3. I can write minus 6. I can write any number. I can write the same number, minus 3. For y value, I can write anything. I can put 2, 5, any number that you like. So these 3 numbers, coordinates satisfy x less than minus 2. Now we'll look at the second question. Write down the coordinates of 3 points belonging to region x greater than minus 1. So first identify what are the x values satisfy greater than minus 1. So what are the values you can take? Don't take minus 1 because that's not included. So greater than minus 1 you can take 0, 1, 2, or you can take the same x values, but for y value you can take any value you like, 3.5 or any decimal or any y value you can write. Question number 3, write down the coordinates of 3 points belonging to both the region x greater than 1 as well as y less than minus 2. So here again 3 coordinates they want. X greater than 1. What are the numbers x greater than 1? You can't write 1 because that's not included. So you can write 2, 3, 5, any x value. But the y value should be less than minus 2. Less than minus 2 means not included minus 2. You can write minus 3, minus 4, minus 5, any number that's less than minus 2. Now we'll take the fourth question. Which of the following points belong to both the regions? It says x less than or equal to minus 2 and y greater than 0. Now look at carefully the x values first. We need x less than or equal to minus 2. So the maximum x value is minus 2 and any value less than. You can take minus 3, minus 5, any x value. So here minus 3 is okay. So this is okay. Minus 2 also okay because it's included. Minus 1, can we take minus 1? No, we can't take minus 1 because minus 1 is greater than minus 2. So we can't take the C point. Now we'll look at out of these which one satisfy for both. Now it says y is greater than 0. What is y greater than 0 means? Any positive value. So now we'll look at this one. This is 0. Can we take 0? No, because this is not equal to 0. What about this one? 1. 1 is greater than 0. So that means the B point satisfy for both these inequalities. Now we'll take the fifth question. Write the two inequalities relevant to the shaded region. Now here there are two lines given. One is dashed line and one is continuous line. When you take the vertical line, we know that how can we write the vertical line? X equals to a certain value. So what is this dashed line? We can write x equals minus 2. What about the horizontal line? Horizontal line passes through the y value 1. We can write this is y equals 1. Now we need to identify which region satisfy for both. If you take this one, this line, vertical line, this is towards right hand side. So the values, all the x values are greater than minus 2. So here we can say this region is x greater than minus 2 because this is a dashed line. You can't include minus 2. When you take this one, so this side y values are greater than 1. So how can I write this one? Y is greater than or equal to 1. Why this is equal to 1? Because this is a continuous line. So 1 is also included. So y greater than or equal to 1. So both these inequalities satisfy with this region. So if I draw separately, you can clearly see that now when you draw minus 2 line, so greater means all these values onto the right. If you draw the other one with y equals 1, greater than side is this side. Now, which part satisfy both of these inequalities? We can clearly see that this region, this is the region satisfy for both. So that's what they colored here, this region. So without, now no need to draw these because they are asking the region satisfy for both. So you need to think about both these two lines. So this is the common region. So what are the two inequalities satisfy for this one? x is greater than minus 2 and y is greater than or equal to 1. Now we'll take the sixth question. It says, in a Cartesian plane, shade the region satisfying the four inequalities. X greater than 1, x greater than or equal to 3, y less than or equal to 2, y greater than or equal to minus 1. So first we'll roughly sketch this and see what's the common region. So when you are drawing the Cartesian plane, first we have to draw the lines. So first x equals 1 line, but with a dash line because 1 is not included. So here x equals 1 with a dash line. Then x equals 3 line. That's also a vertical line. So you can draw a continuous line. Why? This is equal to 3 as well. Now these two are y values. So that means horizontal lines. Y is less than or equal to 2. That means you can draw a continuous line passing through y equals 2. What about this one? Y equals minus 1. This one you have to draw a dash line. So here minus 1, if it's this one, you have to draw this line. So we'll try to draw all of these first. All the lines. X greater than 1. So I need a dash line. So I can draw this line. And what's the other dash line? Y greater than minus 1. So I can draw y greater than minus 1. And here I want to draw the two continuous lines, x greater than or equal to 3. So that means I can draw x equals 3 line and y equals to 2 line. So I can draw this line. So these are the lines. So we'll mark it. X equals 3, x equals 1, y equals 2, y equals minus 1. So those are the 4 lines. Now we'll try to shade it. So we'll use different colors and try to shade it, and you need to get the common region. X greater than 1. So this is our line. So greater means towards right hand side. So we can color this one. Now the next one, we'll take another color. I'll take purple. X greater than or equal to 3. So this is 3. Greater means towards right hand side. I can color with this one. Now the next one, I'll take red color. Y less than or equal to 2. So this is 2. Less than side. Less than side is below. So that's less than side, and y greater than, I'll take yellow color just to identify which region satisfy. Y greater than minus 1. So minus 1 is this one. This is less than side. So greater means above. So I want to color minus 1. Now can you identify the common region for all of this? All the colors you have to find out. So which regions satisfy all these? Can you see? All these I can see. This one. What about this one? Red, green, all colors are there. So that means up to here. Can you see? up to here, this region satisfy all of these inequalities. So here what you can do, first you can draw a sketch and see what's the common region and then shade it on the Cartesian plane. So when you look at the common region, we can shade it with one color. I can shade it here, this one greater than 1 and less than or equal to 2. That means this region satisfy for all of these inequalities. So here it's better to sketch it separately and identify all common region and then shade that one only. Now so far we got vertical lines and horizontal lines. How can we identify vertical lines? When the equation is x equals something. How we identify a horizontal line? Y equals something. But now you are getting y greater than or equal to x. That means what's the straight line you have to draw? Y equals x. So when you want to draw any line, you have to know any 3 points enough to draw a straight line. So here we can take several x values and y values. Okay, I'll take -1. Both are equal, so the y should be -1. If it's 5, this also 5. If this is -3, this should be -3. So we'll take another point. We'll take 10 and if this is 10, this is also 10. Now we'll try to mark this -1, -1. This is the point. 5 and 5. You are getting here. -3 and -3 here. 10 and 10 somewhere here. Now we'll try to draw a continuous line. But why this is continuous? Because this is greater than or equal to x. So here I can draw a line passes through these points. So what is this line? So we can write this is y equals x line. And now we want to shade y greater than or equal to x. So we need to identify by taking several points. Okay, we'll take this side and see whether it satisfies. So we'll take this point. What are the coordinates? 4 and -2. Okay, so now we'll see whether 4 and -2 satisfy this inequality. When you take y value is -2 and x value is 4. Which one is greater? When you compare -2 and 4, we see 4 is greater. So this side, -2 is less than 4. Now, this is not the same side. This is greater, y value is greater, and this point does not satisfy this inequality. So that means the correct region for y greater than or equal to x is other side. So that means you can mark this side as y greater than or equal to x side. So here we can write this region is y greater than or equal to x side. Now we'll take this inequality y greater than -x. Earlier we got y greater than or equal to x. Only difference is now there's a minus sign. How can we draw the line? So we have to draw y equals -x line. So we'll take several points. So I'll take x and y. -1. If this is -1, what's the y value? It becomes +1. -1 into minus. If it's -3, you get positive 3. If this is 5, you get minus 5. If this is 10, you get minus 10. So the sign changes because the line you need to draw is y equals minus x. Now we'll try to mark these points. Minus 1, 1. Minus 1, 1 is here. Minus 3, 3. Minus 3, 3 is here. 5 minus 5. 5 and minus 5. Somewhere here. 10 and minus 10. So somewhere here. Now we need to draw the line, but this is not equal. So that means you have to draw a dash line. So here we can select the dash line and we need to mark. I'll take another point here and try to draw this one. So here up to this point. So this is the y equals minus x line. Now we need to find out which region satisfies y greater than minus x. Now we'll take a point. So we'll take this point, any point here. What are the coordinates? 3 and 3. So here we'll plug this value here. Y is 3, x, negative x. Now it's negative 3 because 3 into negative 1 becomes negative 3. So which one is greater? We know that 3 is greater than minus 3. So we are getting the same inequality. That means this point is on the required region. So here we can mark it with another color. We'll put blue. So I can mark the region satisfy this side is this one. So what's the region? Y greater than minus x. Now we need to find y less than or equal to minus x. Now we did the same line before. We know this is a straight line, passes through these points before. So here this is equal, so we have to take a continuous line, passes through previous points. So here I can draw a continuous line like this. So here what's the equation? Y equals minus x. Now which region satisfy less than minus x? So for that I can take several points. So I'll take this point. When you take this point, what are the coordinates? This is minus 3 and 6. So minus 3 and 6 means we'll take the inequality. Y here is 6 and minus x. Minus into minus 3 becomes plus 3. So which one is bigger? 6 is bigger. So here you get this side. 6 is greater than 3. But the region you want is less than side. So that means the appropriate region satisfy y less than or equal to minus x is this side. So when you want to find out which region satisfy the inequality, better to take a point and decide. Now we'll look at the exercise 25.3 in your textbook. The first question, it says write down the coordinates of 3 points that belong to region y equals x. So that means a straight line. So any point on the line. So you can take any 3 points equals x and y values. So if you take 3, the y value also 3. If you take minus 1, y value also minus 1. If you take 5, y value also 5. So any 3 points you can write like this. Question number 2, it says which of the following points belonging to the region y greater than or equal to x? So that means the y value should be greater than x. Now here this means 5 and 5 means y equals x. Yes, here y is greater than or equal to x means x is equal to y as well. So this is okay. What about the other one? -3 and -2. When you take these two values, -2 and -3, which value is bigger? We know that -2 is bigger than -3. So here this point is also satisfied to this region. What about this one? 0, -1. When you take this one, this is -1 and 0. Which one is greater? -1 or 0? 0 is greater. So this side. But your inequality is this side. So this point is not satisfying this inequality. So which points satisfy this one? A and B. Now look at the third question. Write down the coordinates of 3 points which satisfy both the inequalities y less than -2 and y greater than x. So you have to look carefully both these inequalities. So here we'll try with 1x value. Now we'll take x as 1. So x as 1 means the y value should be greater than 1. So any y value greater than 1, but it says y should be less than -2 as well. So if you are taking the number line, any value greater than x but less than -2. So less than -2 means any value below -2. So we can't write 1 there because there's no value greater than this but less than -2. So here when you are taking the numbers, you can't take for x first. So here you have to take y first. So I can write any value less than -2. I can write -3. I can write less than -2, -6 and -4 for y value. Now how can I find the x value? So the x value should be less than the y value as well. So any number less than -3, I can write -4. Any number less than -6, I can write -7. Any number less than -4, I can write -4.5 as well. Any decimal value or a whole number. So these are the 3 points satisfy both these two inequalities. We'll take the fourth one. In a Cartesian plane, shade the area common to both the regions represented by the inequalities x greater than or equal to 0 and y greater than x. Now we have to draw the two lines. So first thing we have to draw x equals 0 line and y equals x line. Those are the two straight lines we have to draw. But here we can draw a continuous line here because this 0 is included. Here no equal sign, so we have to draw a dashed line. So what can we do? So x equals 0 is a continuous line. So that means a vertical line passes through 0. So that means the y-axis. So this is x equals 0 line. How can we draw y equals x line? We know we did before. Y equals x means all coordinates of x's are equal to y values. So here 1, 1, 2, 2, 3, 3. I can take any 3 points, minus 10, minus 10, 0, 0 or 10, 10. So this is the y equals x line. So here I can write this one is y equals x line and this is the x equals 0 line. Now we need to check which regions satisfy for both. Now here x greater than or equal to 0 means any value above 0. So here if I draw the sketch here, any value greater than 0 means this side. Now the next one is y greater than x. Now the line is something like this, y equals x. So the y value is bigger than x. So when you take any point here, I'll take this any point here 5, 0. I can see that when you substitute 0 for y and x for 5, which one is bigger here? I can see 5 is bigger than 0. So that means this point is not in the correct region for y greater than x. So here that means we have to color this region. That's the appropriate one for y greater than x. Now we need to identify the common region. So what's the common region? I can see the red and blue lines here. So this region. So here how can I mark? On this Cartesian plane I can mark this is the appropriate region satisfy both these inequalities. Now we'll take the fifth question. Write down the coordinates of 3 points which satisfy the 3 inequalities. So here it says x less than 3, y greater than 0, y less than x. So here we'll first see what it means. X less than 3 means x cannot be equal to 3 but any value less than 3. 2, 1. So I can write down the set as 2, 1, 0, any number or decimal place you can write. When you take y greater than 0, that means y should be a positive number. 1, 2, 3, any decimal value you can take. So I can write 1, 2, 3, any decimal value. But here it says when you take the y and x, y should be less than x. So we can start with any value. So less than 3 first. I can write 2, 1, 0 for x value. Now we have to decide what are the y values. So y should be positive as well as that should be less than x. So less than 2, any positive value less than 2, I can write 1. Any positive value less than 1, I can write half. Half is a decimal value or a fraction. What about any value less than 0? Can you write less than 0, any positive value? We can't write. So that means we can't take x as 0 there. So we need to think about another value. We'll take 3 or something. No, you can't take 3. We'll take 2 and then any value, y value should be less than x. So earlier we took 1. I can take 1.5. Y value should be less than x. So these are the 3 points that we can write satisfying for all 3 inequalities. So in this lesson we covered about all types of inequalities. So the first thing we looked at, the main rule that we identified, when you divide or multiply by a negative number, the sign is changing, and for all the other operations, the sign of inequality is not changing. And then we discuss about if the inequality sign with the equal sign, when you want to shade the region, you have to draw a continuous line, and if it's not equal, you have to draw the dashed line. So remember all these steps to do questions in your textbook.